What's up, mathematicians? In this video, I'll be presenting some solutions and hints to practice problems on similar triangles. This video is unrehearsed and unedited, so if I make any errors, let me know about it in the comments. It'd be great. We're going to start with problem number 1, and I will do part B. This one right here. And so the question is, are the two triangles similar? And in order to figure this out, we want to set up a potential similarity statement. So let's figure out what the longest, shortest, and middle sides are. So I'm going to pick some different colors. So here we go. We see those are the longest sides in each triangle. And let's find a different color. How about purple-ish? And then we'll go with the shortest sides in each triangle. So here, oops, no, I didn't change the color. Sorry about that. All right, now this color, right? Did that work? Let's find out. There we go. And those are the shortest sides in each triangle. And then for the in-between sides, let's go with, I don't know, orange color. So those are the in-between sides, not the shortest, not the longest. Okay, so we can see here that we have 12 over 8. Let me pick a different color again. All right, so I'll just pick this color. I'll keep switching. So 12 over 8 would be the relationship of the longest sides. And for the middle sides, it would be 9 over 6. And for the shortest sides, it would be 8 over 4. Right, so let's reduce these fractions. So 12 over 8 will reduce down to, let's see, divide top and bottom by 4. And I'm going to get 3 over 2. And 9 over 6, divide top and bottom by 3. And I will get 3 over 2. So far, so good. And then 8 over 4, divide top and bottom by 4. And I'm going to get 2 over 1. Okay, so here we run into a problem because it's pretty clear that 2 over 1, which is 2, is not the same as 3 over 2. Okay, so these are not equal, and therefore these are not equal. Well, since we don't have this consistent proportionality statement across all three sides, we can determine that these two triangles are not similar. So we'll go ahead and say that, not similar. All right, so I'll let you figure out part A to set up a similarity statement like I've done here. And let's go on to number 2. Okay, let's give myself some space here. All right. Number 2, I'll go ahead and do part C here. And so part C says, all of number 2 says, go ahead and assume triangles are similar and find the values of the variables. I only see one variable, and so I'll go ahead and, I'll go ahead and solve for x, basically. The classic thing in algebra, right? Solving for x. Okay, so first of all, since you're assuming that the triangles are similar, we want to go ahead and figure out which sides correspond with which sides. Well, we'll go ahead and recognize that those two angles must be the smallest, and then these two angles, maybe I'll actually set up some different colors here. So those angles are crossed from two sides that are not given. Okay, so I don't really know what those two sides are, and I don't really care. Let's switch to orange. Okay, so then this side, or sorry, that angle corresponds with that angle, and those are the two biggest angles. And across from those would be these two corresponding longest sides. And get a different color in here. Go back to my green. And we can say that this angle here would be equal to that angle there. Those would be corresponding. And across from those angles are this side and this side. Okay, so now we can see which sides correspond. And so we see 27 and 21 correspond, so I'll say that 27 over 21 is equal to my other two corresponding sides, which would be these two right here. Okay, I'll draw little arrows just to clarify. And yeah, so 63 corresponds with 21 plus 2x. So in order to solve for x, I will cross multiply. And cross multiplication is going to give me, let's see, where do I want to write it? I guess I'll write it. Yeah, I'll write it down here. I'm concerned I'll run out of space, but oh well. 27 times 21 plus 2x is equal to 21 times 63. And I'll go ahead and use my calculator just so I don't make any mental math errors. 27 times 21, so 27 times 21 is 567. And 27 times 2, pretty confident that that's going to be 54x. Is equal to 21 times 63. Again, go ahead and use my calculator. Kind of early in the morning here. Avoid those mental math errors. I get 1323. So now I'm going to solve for x. Subtract 567 from both sides. And so go ahead and say, okay, 1323 minus 567. That gives me 756. And over here I have 54x. All right, and now I want to divide both sides by 54 to get my value of x, right? That'll get x by itself. And so we'll divide this by 54. And that gives me 14. Okay, so x is equal to 14. All right, so that is the value of the variable, which is what you're asked to find. However, I'm also curious to know the length of the side, because x is not the length of the side in this case, it's the value of the variable. So let me actually plug in 14 and just see if we got an answer that's reasonable. So from right here, I'll say, okay, 21 plus 2 times 14, I'm substituting the value for x in, and so that gives me 21 plus 2 times 14 is 28, which equals, let's see, 21 plus 28, last I heard, was 49. And so 49 is a bit less than 63, right? So if we look at this side, that would be that length right there, and we see the corresponding side here is 63. And similarly, 27, a bit more than 21. In fact, we can set up a proportionality statement. Let me actually do that over here. Give myself a little bit of space. Let me actually pick this one, make that one orange. I'm not switching back so much. Okay, so we have the orange side, 63 over 27. Are those equal to the green sides, 49 over 21? All right, so here I'm going to multiply by 9. Oops, I was going to color code this, wasn't I? All right, so the green side's 49 over 21. You know what, I don't need to keep color coding it. I'll just switch back to my purple. So I will divide the top and bottom by 9 in the first fraction, first ratio, and that will give me 7 over 3. And let's divide the top and bottom by 7 in the second ratio, and that will give me 7 over 3, which, guess what, checks out. And so that makes me even more confident that my answer, x equals 14, what I got right here, is probably correct in solving this problem. Okay, so I'm not going to do part A. I'll leave part A to you. And let's go on here. Let's see. Should I do one of these? You know what? I'll do part of part D. I won't do all of it. There are actually 3 variables for part D. I am just going to solve, well, actually, you know what? That one's going to be a bit longer now that I look at it. I'll do part B, and I'll leave the longer, more challenging one for you to figure out. How about that? I just don't want this video to get too long here. All right, so we're going to go ahead and do part B. Okay, so in my longer triangle, let me go ahead and color code sides again. And I'll use orange. So I've got the longer sides in my 2 triangles, or actually, sorry, those are the shorter sides in my 2 triangles. And then the longer side in my small, oops, trying to get this color, all right, there we go. So the longer side in my smaller triangle, but here's the issue. The longer side in my big triangle is not just x. It's this entire length. So it's actually x plus 15. So when I set up my ratios, I'm gonna say, okay, 15 over x plus 15 for the longer sides. And for the shorter sides, it's going to be 7 over 11. Okay, so first thing I do is cross multiply, which 15 times 11, well, 15 times 10 is 150, plus 15 is 165. And then I have 7 times x plus 15. Okay, so I'll distribute the 7, and I get 165 is equal to 7x, and 7 times 15 is 105. Like I said, it's early. Hopefully my mental math there is correct. Pretty sure it is. Okay, and so I'm going to subtract 105 from both sides because I am solving for x. 105. Okay, and that's going to leave me with, myself a little more space here, 60 equals 7x. So I'll divide both sides by 7, and I get that x is equal to 60 over 7. So in terms of exact answers, you know, that's fine. The thing is, you know, we can't reduce that fraction anymore, right? 60 over 7 is in reduced terms. Now you might say, well, I don't like a big fraction like that. Well, then we can just go to the calculator and say, okay, 60 divided by 7, get more decimal places than we could ever even want. And we can say, okay, then, well, x is also approximately equal to 8.57, if you prefer that. So I'll go ahead and leave that one there, and I'll leave part D to you. Okay, so now let's do some application problems. First off, number 3, that's a pretty straightforward one. That one, you know, definitely draw a diagram for these, but I'm guessing if you spend a little time with that one, you could probably do it in your head without a diagram. Probably, but you know, if you don't see that, don't feel bad. You know, draw a diagram, work it out. I'm going to skip down to number 4. Number 4 says a statue honoring Kobe Bryant can be found outside in the or in Los Angeles, outside the Staples Center. I assume it is. I've never actually been there, but let's assume that this is true. Not that it matters. It doesn't change the problem. So note that the red bar represents a mirror. That's important because when light reflects off a mirror, it leaves from the same angle that it comes in at. Another assumption we have to make here is that the statue is pretty much a right angle and the person standing is pretty much at a right angle. Well, if those things are true, then this angle up here, the third angle of the triangle, those two angles must also be equal, which means that, of course, we are dealing with similar triangles. So we will come up with our corresponding sides. And so we have corresponding sides at 4 meters and 2.4 meters, and we have corresponding sides at x and 1.8 meters. So we'll go ahead and set up our proportionality statement with those values. So first I'm going to say x over 1.8 is equal to, let's see, big triangle, we got 4, and small triangle, 2.4. And now I'm going to cross multiply. So first of all, x times 2.4, I'm actually going to put it over here. I have 2.4x, and 1.8 times 4 is equal to 7.2. Should have done that one in my head, but you know, like I said, it's early. Give myself a break. Now I'll divide both sides by 2.4 in order to solve for x. Okay, so 7.2 divided by 2.4, I do actually know that that's going to be equal to 3. So x is equal to 3 meters. And that is our answer for the height of the statue. So 3 meters. Okay. And let's go ahead and skip number 5. Number 5 is a little bit more straightforward. Number 6 actually gives students a fair amount of difficulty, I found. So let's talk about number 6. And I don't know if I'll actually solve the whole thing, but I'll set it up for you. So this one, you definitely need to draw a picture. I'll tell you that much right now. So first of all, we have our ground. And on this ground, we have a lamp post. I'm going to draw a very beautiful artistic lamp post. I'm sure you'll all be impressed. All right, how about that lamp post, everybody? You like that one? Tell me about it in the comments if you love that lamp post. All right, and then we have, it says a girl standing some distance from the lamp post. So here we go. Clearly is very happy to be standing some distance from the lamppost. And what is that? What is this distance? Well, this says this distance is 360 centimeters. 360 centimeters. Okay. And it says the girl is 160 centimeters tall. So 160 centimeters. Okay, and now it says her shadow is 90 centimeters long. Okay, so basically this light is coming down from the lamppost, and the end of her shadow is here. This is, oops, sorry about that, 90 centimeters. Okay, clearly this is not to scale, and that's fine. When you draw a diagram, sometimes, you know, you can't visualize exactly what the proportions are going to be like, so not at all to scale. But that's fine, we have enough information. Now the question here is, how high is the lamppost? So we'll go ahead and put an X by the lamppost to indicate that's the height we're trying to solve for. And so what are the sides of my two similar triangles. We can see the two similar triangles here, right? And so first of all, for the smaller triangle, we have 160 centimeters and 90 centimeters. For the larger triangle, we have, oops, trying to color code these and it's not switching. There we go. X and wait a second. Not 360, right? In fact, I want to give myself a little more space here. Instead, for the large, for the side along the ground of the larger triangle, I need to add 360 to 90 to get this full length, which will be 450 centimeters. Okay, so for the larger triangle, I have X and 450 centimeters. So now my proportionality statement, let's see, for the small triangle, it's going to be 90 over 160. Of course, I could just as easily do 160 over 90 as long as I'm being consistent. And so the side corresponding to 90, the bottom, is 450. And the side corresponding to 160 is X, the thing we're trying to solve for. Okay, so that right there is the proportionality statement. I've done all the hard work. I'm going to let you finish this problem and solve for X. But really, the bulk of the work in this problem is just understanding how to draw the diagram and, understanding that, hey, 450 is the length along the bottom, not 360. So setting up that statement properly. Okay. So I'm going to go on to the next problem here. Or let's see, the next one. I'm actually going to skip number 7. I'm going to do number 8. I'll let you all figure out number 7. And I am going to do number 8. And so here we go. Pull out my purple pen, my default. And so I've got two triangles, IJK, TUV, that are similar. The lengths of IJK are 40, 50, and 24. The length of the longest side of TUV is 275. Okay, so TUV is quite a bit bigger than IJK. I'm not going to draw it to scale exactly, but I'll go ahead and draw my two triangles first. Okay, so this will be I, J, K, and the sides are, let's see, the longest one is 50. I'll put that down here, and then 40, and then 24. Okay, and now we'll draw the other triangle. T, U, V, and it says the longest side is 275. Okay, now it's asking me to find the perimeter of TUV, which this does trip up students because they'll say, well, wait a second, there are two sides that I don't know here. That's true. However, you do have enough information to find the perimeter of IJK, the first triangle. You just add up those sides and you say, okay, 50 plus 40 plus 24, and let's see, 50 plus 40 is 90 plus 20, oops, I wrote that wrong. I was about to get some nasty comments there. People saying, you made an error. All right, so let's try that again. 50 plus 40 is 90, plus 24 is 104. So the perimeter of IJK is 104. And since all the sides are proportional, the perimeter will also be proportional, it turns out, which is not something, I talked about in the videos, but intuitively, that should make sense. So what we can do for our proportionality statements are, number 1, use the sides that we know, 50 and 275, and number 2, use the perimeters, which are 104 and 275. Oops. Wait, no, I said that wrong. Actually, x. We don't know the perimeter of the larger triangle. And so we'll call that x. And so we'll set up our proportionality statement as follows. The smaller perimeter, 104, divided by the larger perimeter, x, is equal to the smaller side, 50, and the side in the small triangle, 50, and the side in the large triangle, 275. Okay, so now I can cross multiply and solve for x. So I cross multiply. Need some a little more room just in case I run out of space. And I cross multiply and I get 50x is equal to, I'll go ahead and use the calculator here, not subject my brain to too much strain this early hour. There we go. So according to this, I get 28,600. So I'll divide both sides by 50 to solve, to get my value for x. Okay, so divide by 50, and that gives me 572. So there's my answer. The perimeter is 572. Or wait, yes, that's right. Excuse me. So the perimeter of the large triangle is 572 units. It doesn't really specify the units, so whatever the units are. Okay. Ooh, number 9. Oh, this is a fun one. Do I want to do this one? Part of me wants to do it because it's so much fun. Part of me says, no, students should have the fun of doing this whole thing. Well, maybe I'll talk about it a little bit, call this a hint rather than a solution. Okay, and yeah, I'll give you a hint. So first of all, I would go ahead and draw the triangles. So as I did in the instructional video, we have 2 triangles, and I'll try to make them look more or less similar. So we're going to say, okay, this angle corresponds with this angle corresponds with this angle, and this angle corresponds with this angle. And we have 3 corresponding angles that are equal. And we'll call this triangle A, B, C. And this triangle D, E, F. So triangle A, B, C is similar to triangle D, E, F. Okay, this little curly line indicates that they are similar, not necessarily equal or congruent, but similar. Okay, so I'm going to use the naming convention that I discussed in the video. So this would be lowercase b, lowercase a, lowercase c, and lowercase e, lowercase d, lowercase f. And so if that's true, if the 2 triangles are similar and the sides are labeled as I have right here, then our proportionality statement is A, oops, sorry about that. Let me erase this. A, wow, I'm not, okay. One more time, 3rd time's a charm. There we go. A over D is equal to B over E is equal to C over F. All right, now what I'm going to say is that in order to prove that AB equals DE, just take these 2 statements from that proportionality statement, and I'm going to write it over here. So AD is equal to B over E. So we want to say we can't go across triangles, right? So like A over D, or we can instead do, and maybe I'll use colors, right? Instead of going A over D, I could go A over B. And in my other proportionality statement, d over e, using the same using sides in the same triangle for each proportion, and that turns out to be equivalent. So to prove that algebraically, take this right here and do your cross multiplication, and then do a little algebraic magic and see if you can come up with this ratio right here. Okay, so that's my hint. I won't continue. I'll leave it right there. All right, let's see. How many more of these do I want to go through? So 10 and 11 have diagrams already, which make them a little bit easier. So maybe I'll do number 12. And I'll leave 10 and 11 to you. All right, number 12. So draw a diagram, because you see there is no diagram given. It's just a description. So, okay. I have, you have to understand what it's saying. So the foot of a ladder is 0.8 meters from a fence that is 1.8 meters high. So we know we have a fence, we know we have a ladder, and it rests against a building that is 2.2 meters behind the fence. And determine the height on the building reached by the top of the ladder. Okay. So we have ground. I'll go ahead and draw ground. We have a building. That'll be my building. We have a fence. That'll be my fence. And we have a ladder that just touches the top of the fence and reaches some point on the building. Okay, so here we go. This is my beautiful, so artistic ladder. Talk in the comments about how beautiful that ladder is. I hope you do. All right. Okay, so now let's go ahead and specify the dimensions. And again, this is not going to be to scale, of course. So the picture doesn't always provide scale, but it does provide important information, visual information for us to set up the problem. So the foot of the ladder is 1.8 meters from the fence. So, sorry, 0.8 meters. So this is 0.8. And the fence is 1.8 meters high. So 1.8. All right. Now, the distance from the fence to the building is 2.2. And it says determine the height of the building reached by the top of the ladder. So this right here, this length, is my x. That's the thing I want to find out. Okay, so keep in mind one side of the larger similar triangle will be across the whole bottom here from the base of the ladder to the base of the building, and that's going to be 3, right? Because 2.2 plus 0.8 is 3. Okay, cool. So I can set up my proportionality statement as follows. Well, let's go ahead and talk about which corresponding sides we have. So we have 1.8 corresponds with x, and we have 0.8 corresponds with 3. So I'll write that one first. 0.8 over 3, and 1.8 from the smaller triangle over x from the larger triangle. And we cross multiply, and I get 0.8 x is equal to 3 times 1.8 should be 5.4. And so we'll divide both sides by 0.8. And so I get that x is equal to 5.4 divided by 0.8. And that gives me 6.75 meters for my answer. All right. And let's see, I don't want to go too long in this video. I've already been going, I don't know how long, probably what, close to half an hour or so? Ooh, more than half an hour. So, all right, you know what? Maybe we'll just leave it there. Maybe that's it. I think that's That's a reasonable number of examples for me to go through. And some of these, might be a little more challenging than the ones earlier, but with some determination and ingenuity, I think you can do it. I think you got this. All right. We're going to go ahead and wrap up this solutions and hints video there. Of course, I did not cover all the problems, but I got to leave some of the fun for you, right? So that's it. I hope this was helpful for you, and I look forward to explaining more problems in a future video. And we'll see you then. Bye-bye.